I'll call this capacitor C1. At steady state only. Again, we are doing the problem at steady state. So what you have to check it like, if there's a one capacitor, okay, we can manage. If there are two capacitors, we'll search for series parallel something. So here we have something three capacitors. So we have to be alert how they are. If they are series, okay, one way of giving charges. If they're parallel, one way of giving charges. So even at steady state also, that idea of series parallel will come into picture. That's what this question is saying. 8 ohm, 13 ohm, 1 ohm, 2 ohm, C2 will give name C3. Or let this be C2, this be C3. How to find out the steady state charges here? Again, I'll go back to the basic concept. Charge of a isolated junction. Initially, there is no charge. Before switching on the circuit, there is no charge in the initial charge in the capacitor is 0. Then I'll switch on the circuit. Then charge at steady state. See, sir, initial charges they didn't mention. If initial charge is there, I'll mention. Otherwise, it is assumed that it will be 0. There's a convention you have to follow. Even you check the advanced papers, they use same thing. They didn't say anything about initial charge. So will you assume? No, nothing. 0 only. If they mention, you take that initial charge. If they don't mention, you have to assume initial charge to be 0. Initial charge in capacitors is 0. The cells are switched on. Now what happened? We are finding at steady state what will be the charge. Are they series parallel? No, we can't say anything. So what I do is I'll go for the distribution of charge. Q1, this will be Q2, let this be Q3. So according to conservation of charge principle, Q1 plus, earlier what was the charge at junction J? This was the junction J, no? So at J, charge should be conserved. So initially 0. Finally, how much it should be? Minus Q1 plus Q2 plus Q3. So therefore, Q1 equal to Q2 plus Q3. So one equation I got it. Huh? So what we have to do? We have to try for two more equations. Now what are the two more equations? Writing loop equation. So what we needed, just look at the points here. These are the points A, B and C. At steady state, how the circuit will behave. How the circuit will behave at steady state. So where all capacitor there, shall I put open circuit? That was the at steady state how the capacitor, where all capacitors are there we have to put open circuit. No? So at steady state, no charge with there. So I'll remove this capacitor itself. So here it will be like this. Huh? Will there be any current through the capacitor branches? No current will flow. C1. So no current will flow through here. So where the current will flow only through these two loops. So let's push the current. So let this be I1. So let this be I1. So let here current be I2. Here I1 plus I2. So give the polarity plus minus. After all, it's just writing loop equation. Nothing big is there. So only just you should develop this particular method. So writing loop equation. So two unknowns are there, I1 and I2. Solving, writing two loop equations where I1, I2 are involved. Solving that will get I1, I2. Once you know I1, I2, then you can find out VAB, then VAC, then VBC, then Q1, Q2, Q3 are involved. So I'll proceed with the mathematical part. Okay, I'll directly come for the second part of the problems. In the second circuit, looking at that, I'll write the KVLs. So they should be equal to,
Sir,
yeah.
sir, when are we supposed to replace the capacitor with open circuit, and when are we supposed to replace it with cell, sir?
So here at steady state, after a long time, and we are discussing problem after long term. In the first circuit, it's a steady state only. To make clear that at steady state no current flows, that's why I'm showing the second diagram. Both are at T equal to infinity. Both the circuits are T equal to infinity only. Both the circuits are at T equal to infinity. To make the have a clarity that no current flows to the capacitor branch, I'm showing open circuit. At steady state, capacitor open circuit. At T equals 0, capacitor short circuit. At any time T, it will have capacitance and charge. At steady state also, it will have charge. Okay, fine. So looking at this, right equation for KVL, you write it 24 plus 5I2 plus 2I2 minus 1 plus I2 plus 2I2 minus I1 equal to 0. Now, what is this path? We have traced it like this from here. Plus 24 plus 5I2 plus 2I2 minus 1 plus I2. Here current I2 will flow.
Sir, the
Okay,
current to
plus
8 ohm
I2.
resistor should be I1 plus I2, sir.
Which resistor? This one, huh?
8 ohm resistor, sir.
I1, oh, plus symbol. Okay, everything fine. All symbols, signs. Thank you. So plus minus 1 volt plus I2 minus, this will be plus 2I2 minus I1. I'm going from positive equal to 0. This is the one equation. So here 24, 5, 2, 7, 7, 10 I2. 24 minus 1, 23. So this is the equation 2. So one more equation is needed. So you can choose the smaller loop. Less elements are there. 24 minus 8 I1 plus I2 minus 13 I1 plus I2 minus I1 equal to 0. So 24, 13 plus 8, 21, 21, 22 I1. Check once the, so solving 1, 2, 3 will get Q1. First, I think solving 2, 3 will get I1, I2. Is that one? After getting I1, I2, then we have to calculate VAB. How to calculate VAB? Writing loop equation again. Then we'll get Q1. I don't know. Somebody asked this question in the objective for 3 marks in the advance, no, in last year. So in spite of that, we asked him, it's very lengthy, no, can you solve yourself by 3 minutes? No answer. It's like whether wrong or right, you tell me, we can't do anything that one. So this is what happens in not all, some questions. At least 25% of questions will be very lengthy. Nobody can solve within 3 minutes. And anybody solved, he must have done that, or he might have known the most of the steps or most of the answers he might have known, then he could have done that one. After this, what is the next part? VAB, we have to write it. VAB plus Q minus Q. Just only that steady state charge also, you have to take care about all the basic circuits what we did. There's the only purpose why I brought this problem. You can't just put things. You have to follow again the same basic charge distribution rules. So writing loop equation, VA Q1 by C1 minus this is Q3. VA minus this will be Q3 by C3 minus VC equal to 0. VAC, how to calculate VAC after getting I1, I2? Again, we have to calculate VAC. How to calculate VAB? Symbol VAB. I'll make it small so that everything will be visible for you. Now try to see this. So first, after getting I1, I2, what you should do, you have to calculate VAB. How to calculate VAB? Again, writing KVL. Writing KVL. Again, write KVL, you'll get VAC. Then VBC. After that, again, looking at the first circuit, calculate VAB. So what about VBC? VBC, you can use this method. VB minus plus Q3 by C3 minus Q2 by C2 minus VC equals 0. I'll just write the equation. Later on, you can solve it. If time permits, you solve it or just leave it. Doesn't matter. Okay, how to calculate VAB, VB? So again, writing KVL from A to B. After getting I1, I2, write KVL from A to B. Okay, it's a very big story here. So just learn the method. Conservation of, even at steady state also, we should follow the conservation of charge principle.
Sir, in the third equation, it is VC, sir. Euro VB.
Correct, no?
Last one, sir, blue color.
Blue color.
Last
the
one, sir.
VAC.
It is minus VC.
VC. Okay, thank you. So one VAB, how to get it? VAB again, VAB, VBC, VAC are unknown. After getting I1, I2, you have to calculate VAC, VAB all.